Now we will do the distinguishing test. Theory I have shown you already. Distinguishing test between lead and zinc ions in practical chemistry. So we have taken lead nitrate and lead nitrate solution. So the lead nitrate solution. To the lead nitrate solution, we will add NH4OH. Heavy white precipitate, chalky white precipitate is formed. Now this, wait, I will show you side by side, okay, so that you can, it will be very, very clear. And this is zinc sulfate, a zinc Zn2 plus ions. Now the Zn2 plus ions also we dissolve in water. Solution, aqueous solution has to be taken. I am decanting it, okay, it is soluble, it is dissolved. So in this we will add NH4OH. Gelatinous white precipitate is formed. See the difference. This is the chalky white, but both are white. That is why it is not a distinguishing test. Now how will you distinguish between Pb2 plus and Zn2 plus? On the solubility of the precipitate in excess of reagent. So here first we will take lead, throw the precipitate out, take a small amount and check whether it is soluble or not. Insoluble, remains as it is. You add excess of reagent, it remains as it is. So it is insoluble in excess. Lead hydroxide is insoluble in excess of ammonium hydroxide. But this is zinc, the gelatinous white precipitate. This I will throw and take a small amount. Whatever is sticking to the walls of the test tube. Now to this we will add excess of ammonium hydroxide. See, it dissolves. So this is the distinguishing test. With NH4OH, lead is insoluble in excess of reagent, lead hydroxide, and with zinc, zinc is soluble. Why is it soluble? Zinc hydroxide forms a complex salt called tetraamine zinc. Okay, that tetraamine in zinc is a transparent tetraamine zinc sulfate because we have taken sulfate over here. So tetraamine zinc sulfate is formed, and that is a soluble salt. You can see that the solution has turned transparent. So that was the distinguishing test between lead and zinc. Now see, there is another difference, that is with copper. Copper, we take copper sulfate solution first, we will make copper sulfate solution. We will decant out the clear liquid so that you are not confused with the precipitate and the insoluble copper sulfate. We take the clear liquid. Now to this we add ammonium hydroxide. See, in drops I am adding. Okay. So when you are adding in drops, you get a pale blue precipitate. This is the pale blue precipitate that you get. When a few drops of ammonium hydroxide is added to copper sulfate solution, you get a pale blue precipitate. What is this? Copper hydroxide, CuOH2. That pale blue solution, in NaOH also it gave pale blue precipitate, not solution, sorry, precipitate. So pale blue precipitate of copper hydroxide, in NaOH also you got that, but that was insoluble in NaOH. Here we have taken ammonium hydroxide, and in ammonium hydroxide, to this pale blue precipitate, it's the precipitate, to this if you add excess of reagent, means excess of ammonium hydroxide, then see what happens. It turns, the precipitate dissolves, and you can see through this liquid, this is a transparent inky blue solution. So this is the test of copper ion. Inky blue solution is formed. If you are asked in the question, What happens when excess of NH4OH is added to copper sulfate solution or to cupric ions? The answer is not a pale blue precipitate. You will write when we add a few drops, then we get a pale blue precipitate. On adding excess, the precipitate dissolves and inky blue solution is formed. Please pay attention, please pay emphasis to the word precipitate and to the color. Pale blue precipitate, and then when it is added in excess, when NH4OH is added in excess, then inky blue solution is formed. Inky blue is equally important, and of course solution word has to be there. Inky blue precipitate dissolves and inky blue solution is formed. So this is how the analytical chemistry works. Now in this chapter only we will do one more thing, that certain metals, their oxides and their hydroxides. Usually metal oxides, metal hydroxide, they react with acids to give salt and water, what we know as the neutralization reaction. But there are certain metals, their oxides and their hydroxides, which also react with alkali to give a new series of salt, another series of salts. So these are called the amphoteric oxides or hydroxides. For example, lead, zinc, aluminium, tin, germanium. So there are some metals which are called amphoteric, which have amphoteric nature. They react with acid. For example, say zinc. Zinc with HCl will form ZnCl2 plus H2. Zinc with H2SO4 will form ZnSO4. So with acids it is reacting, and with alkali also it is reacting. Usually a metal oxide will not react with another hydroxide, or a hydroxide will not react with a hydroxide. But these metals, the amphoteric metal hydroxides, the amphoteric metal oxides, or the metal itself, they will react to form a salt. Okay. So Zn plus 2 NaOH giving Na2ZnO2, sodium zincate, and hydrogen is liberated. Zinc oxide will form the same Na2ZnO2, but water. Another product is water. Zinc hydroxide, zinc oxide, zinc hydroxide. All of them will react with sodium hydroxide to give sodium zincate, and if it is only zinc, then it will form hydrogen, displace hydrogen, and otherwise water is the other product. Similarly with aluminium also, meta-aluminate is formed. Sodium meta-aluminate is formed and hydrogen is displaced. Aluminium oxide, same soda meta-aluminate is formed and water is formed. Here also the same. With lead also you get Na2PbO2. Sodium zincate is here. With lead you will get sodium plumbate. So these are called amphoteric metal oxides or amphoteric metal hydroxide. Sorry.